Now that we've defined a relation and a function, what I like to do is determine how to graph one of these things given an equation. So here we have the relation x plus y is equal to 4. Now there's a couple of ways we could go about this. We could just try to think of numbers that make this true, which I don't think would be very difficult. Another approach would be to solve this equation for either x or y and use this to figure out points that lie in the graph. I'm going to take the second approach here for this problem. What I'm going to do is start with x plus y is equal to 4. I'm going to subtract x from both sides, so I'm choosing to solve it for y, and that's equal to negative x plus 4. Once I've done this, I can create a table of values for x and find their corresponding y values. It doesn't matter which numbers I choose. You can really pick anything that you'd like, but I'm just going to choose, I guess, maybe negative 2 to positive 2, just to get a few values on here. I'll take negative 2, put it in place of x, and solve for the corresponding y value. I think I can do that one relatively easily here. If I put negative 2 here, negative is a positive 2, plus 4 gives me 6. What this means is at negative 2, we get the value 6 back for y. Okay, if we continue in this way, here I have negative 1. I put that in place of x. Negative 1 is positive 1. Plus 4 gives me 5. So at negative 1, I get 5. All right, if I put 0 in place of this x, this whole part is just 0, and I'm left with 4. Great. That's the point 0, 4. If I plug in 1, I get negative 1 plus 4 is 3. And then for 2, I get negative 2 plus 4, which is 2. You only really need as many points as necessary to understand the entire graph, but I think I get the idea. The graph of this appears to be the straight line going through these points. So I get this thing here. So to get the sketch of a graph, you can take your relation, solve it for one of the variables, and then make a table of values enough so that you think you understand what the entire graph looks like. All right, now from the graph, I want to figure out, well, what is the domain and what's the range? So the domain of this function as I travel along here is going to be all of the corresponding x values. I can see that the domain of this relation is all real numbers. It's everything from negative infinity to positive infinity. The reason for that is, if I pick a spot on this graph and I look down to the x-axis, I get every single x value back. I don't miss a single one. Since this graph is going forever in this direction, you're getting all of those x values in return. Since the graph is going forever in this direction, you get the corresponding x values in return as well. And the same thing holds true for the range. The range of this is also negative infinity to positive infinity. This graph goes up forever and it goes down forever. That means you're getting every single possible y value back. So we started with the relation, graphed it, and then from the graph was able to determine the domain and the range. So the last thing here is the relation also a function? And the answer to that is yes, this is a function. At no point on this graph is there one y value above the other. Like if I look at this spot here, I look up and I look down and I never have another y value for this particular x value. This is always the case. Any x value you choose, you get a y value, but you don't get anything else above it or below it. Since that is true for every point on this graph is in fact a function. So for example 2, same idea. We're given this relation as an equation, y is equal to negative 2, and I want to get its graph. Now this one's a little strange because it is solved for y, but there aren't any x's in it, so it kind of makes it just a little bit confusing. Like, what is this thing going to look like? So I'm going to take the other approach where I'm going to try to guess points that make this true, and then from that get the entire sketch. So we're guessing some points. So what I want to do is think of a point that when I plug it into this equation, it makes it a true statement. So again, we're dealing with y is equal to -2. So I'm just going to pick a point at random. I don't know, maybe the point 5, 5. I don't know if it works, but I'm going to try to plug it into this relation to see if it makes this a true statement. So let's see. So it's kind of just a question at this point. Does 5, 5 work in this relation? Well, 5 is the x value, but there's no x's in here, and that just means 5 doesn't go anywhere. This 5 represents the y value. Okay, that definitely goes right here. When I plug that in, I get 5 is equal to -2. Is that true? No. And all this means is that 5, 5, I can't use this point. This point is not on my relation. But now that I see a little bit better what's going on here, the issue was putting a 5 in this spot. I mean, really, I should have put -2. So I'm going to make another guess. I'm now going to guess, well, what about 5, -2, which is located right here? Does that point work? So in my relation, this 5 goes in place of all the x's, but again, there are no x's, so this 5 doesn't go anywhere. But this -2 goes in place of this y. So let's try that out. So I take that -2, put it in place of y, and that's going to be equal to -2. And is this a true statement? Yes. So I get the point 5, -2. And once I see this, getting the rest of the graph is pretty simple. By that I mean, well, what if it was 4, -2? Is 4, -2 going to work? Of course it is. And the reason for that is because this -2 goes in place of the y, making this a true statement, and the 4 is essentially irrelevant. It doesn't go anywhere. So the point 4, -2 also works. But so does 3, -2, 2, -2, 1, -2, 6, -2, and so on. We get all of those points. I think I know what the entire graph looks like. It's going to be the horizontal line that goes through y is equal to -2. All right, so that's good. Now that I have my graph and I believe that this is the entire relation, this horizontal line, I want to figure out the domain and the range. So the domain of this function, since it's going to the left and the right forever, it's going to be all real numbers. We get everything from -infinity to +infinity. But the range in this case is going to be different. The range is how far up or down the graph goes. But in fact, the graph is always stuck at -2 for y. The range in this case is just one number, -2. It never moves up, it never moves down, and that's the only y value you get back. The last piece would be, is this relation also a function? And the answer is yes, this is a function. And the reason for that is, no matter what x value you choose, you only ever get one y value back for that corresponding x value. So at -4, there's this one spot. There's nothing else above it or below it. And that is it for this example. So before we get to the last example, example 3, I just want to go over one definition quickly here, and that is, what is the absolute value of a number? So if you're familiar with absolute value, it's very easy to define it as, if you take the absolute value of a positive number, it's just that number, but if the value inside were negative, it just makes it positive again. A more formal definition of absolute value is the distance something is from 0. So if you're over at 1, 2, 3, 4, 5, the absolute value of +5 just means how far you are from 0. And of course that distance is 5. But if you went to -1, 2, 3, 4, -5, the distance -5 is from 0 is also +5. You want to record distance as positive. But either way, the absolute value boils down to, if you put a positive number inside of it, it's just that number. If the absolute value is negative, just make it positive. Using this definition, I want to graph the relation the absolute value of y is equal to 6. What does this thing look like? This one's tough because you can't really solve it for y. Again, I think we're going to have to use this sort of guess some points approach to figure out what it looks like. Let me think. Using what I know from the last example, I think I have some better guesses this time. Here's what I mean. I'm going to guess the point, well, since I see, y here and I want 6, choosing 6 for y is probably a good idea. So maybe I'll start with the point, 2, 6. Does the point 2, 6 work in this relation? 2 goes in place of the x's, there aren't any. 6 goes in place of the y, which I'll put right here. And does it make this a true statement? Is the absolute value of 6 equal to 6? And the answer is yes. Therefore, I know the point 2, 6 is on this relation. But for that matter, so is 3, 6. Or really any number, 6. So we get 3, 6, 4, 6, 5, 6, 1, 6, 0, 6. We get all of those numbers. So I'm going to go ahead and just draw that in. There we go. But are there others? This is not the entire picture, and the reason is you can also put -6 in place of y, and the absolute value of -6 is equal to 6. So what about this point? What about 2, -6? Does this work? Well, 2 doesn't go anywhere. -6 goes in place of y. Is the absolute value of -6, 6? Yes, it is. So this means you also have 2, -6. Well, what about 3, -6? Yeah, that works too. So does 4, 5, and 6, -6, and 1, -6, and so on. So this relation with the absolute value is actually just a little bit more complicated. It's not just a horizontal line at 6, but it's also a horizontal line at y is equal to -6. We now have the entire thing graphed. So what's the domain and range? Now, this graph goes to the right and to the left forever in both places, so I know the domain is going to be all real numbers. There's no problem there. But now, the range is actually 2 separate values. All the y values are either +6 or -6, and there isn't anything else. So that's -6 and +6. And lastly, is this thing a function? Absolutely not. This is not a function. And there's a lot of places you could look at. But here's one. At 2, you get 6, and you also get -6. It happens every time you plug in any x value, but it just has to go wrong once. And because it happened once, it means that this thing is not a function.